Well, hi there. Now, we're going to be looking at section 11.5, and then we're just going to do 11.6 and we're going to be done. But I did want to touch on 11.5. We're not going to spend a lot of time on this. It's making a non-quadratic equation look like a quadratic equation, so that if you needed to, you could use the quadratic formula to solve it, or you could factor to solve it. And on a lot of these, you don't necessarily have to use substitution, but I wanted you to be introduced to substitution so that your later classes, when they do talk about it, at least you have some idea of what's going on. So we're going to be looking at equations that are reducible to a quadratic. Now, substitution won't work on all equations. And so, I mean, you can always try substitution and see if it makes it into a quadratic, and then go from there. But like I say, you know, as you get into upper level, there's more than one way to solve an equation. And so now we're looking at some alternative methods. But as a review, we're going to go ahead and use the methods that we had used in the past. And then we're also going to use substitution to solve it. And then you can make a choice as to which one you'd like to use. And on some of those, the last one we're going to do, substitution would really be probably one of the only ways that you would want to solve it. Okay? All right, so what we're going to do is we're going to take an equation that doesn't look like a quadratic again, and we're going to change it into a quadratic. And these are the steps that we're going to go through. And we'll go through an example, and we'll talk about each of these steps as we go through an example. And again, step 5 should be for all of them, and that is to check your answers. Make sure you put them back in to see that the left is equal to the right. All right, well, we're going to go ahead and we're going to look at an example, and then when we do the substitution, we'll go through these steps with the substitution. But given this right here, actually you were given something similar to this in chapter 6. And so you don't necessarily have to use substitution. Now, you could factor it. What you could not use on this is the quadratic formula right now. So if you wanted to use the quadratic formula, it might be tempting to say, okay, A is 1, B is a -9, and C is 8. But you can't do that. Okay, you won't get the right answer for X. You won't get the value of X that would make the left side 0. So you can only use the quadratic formula. I need to stress that when your highest power is a 2. And in this case, it's not. It's a 4. Your highest power is a 4. So we're going to use the methods of chapter 6, and then we're going to apply substitution and solve it that way as well. So let's use the methods from chapter 6. We're going to factor it. So I'm going to break it down here. Well, I'm sorry. I'm going to go ahead and use, I've already done this just to kind of save some time. So this is our x to the 4th minus 9x squared plus 8 equals 0. Now, some of the directions, it may not say, you know, solve this. It may actually say, you know, here's your function, find the x-intercepts. So as a review, remember that when you want to find the x-intercept, the y is 0. And so if this were an f of x or equals f of x here, or equals y, the f of x would probably be on the left, but I didn't have a lot of room. If they wanted to, if they gave you the function and function notation and asked you to find the x-intercepts, that means you set the function equal to 0 and solve it. All right, so just kind of be aware of those instructions. Okay, but we've set it equal to 0, and now we're going to solve it. Well, the first thing we do is we factor it. All right, so x squared times x squared, again using the FOIL, gives you x to the 4th. And then we have the outside, -1x squared, -8x squared, give you a -9x squared. And the last times the last gives you 8. So then once it's factored like this, we know using the zero product property that one of these numbers, either this number here has to be 0 or that number has to be 0. So we set both of those equal to 0, which means Now we're going to skip to chapter 10 and solve this. All right, or was this chapter 11? It was chapter 11. Okay, so solve, doesn't matter, we've done it. So when we solve these, rather than factor, we now know that since we don't have that linear term, we can just bring the 8 over and take the square root of both sides. So we learned another method earlier in this chapter to solve these. So on this first one, I add 8, okay? On this one, I add 1. So you're isolating that x squared. Now you can use this method as long as you don't have an x to the first, okay? Then we have to use either the quadratic formula or something like that. Once you've got the 8, once you have the x squared by itself, okay, then you take the square root of both sides to solve that. And so then the tricky part here is to remember, well, that you'll have plus or minus the square root of 8. X equals plus or minus the square root of 8, and x equals plus or minus the square root of 1 is 1. So don't forget those plus or minuses. This 8 can be broken down, okay? So always try to remember to do that. And so this 2 comes out in front. I have my plus or minus, because I had a squared, I had 2 answers. So plus or minus 2 square roots of 2 is what we come up with. So again, our highest power was a 4. And if you look here, we actually have 4 solutions. We know we couldn't have more than 4, but we could at most have 4 solutions. Plus or minus 2 square roots of 2, plus or minus 1. And then I would leave the check up to you. You would substitute those back in for the x. And again, when you do the negatives and you have an even power, use parentheses around that negative power and then put it to the 4th power or to the 2nd power. And the left should equal the right. So I'll leave the check up to you. Well, that was using methods previous. So now what we're going to look at is we're going to use substitution on this one, okay? So I had started with the parentheses, but here. Okay, substitution. We're going to be using a U substitution, and U is going to be, U will be this power right here. Okay, so in this case, U is going to be equal to x squared. And as we go through the example, you kind of catch on. If I square this, if I square this side, I square this side. When I square this, okay, I squared the left, I have to square the right. When I square this, you remember you multiply a power to a power. And so we end up with U squared equaling x to the 4th. And this right here should always match this right here when you square your U. Notice I didn't do the 9. I'm just doing the variable part. So we now have, we're going to use substitution. We're going to substitute these values in up in here. So your U, you start out with the U and look at your middle term there. That's where you're going to get your U. U is x squared. And then you always square both sides. And again, when you square, you multiply a power to a power, you get x to the 4th. So our equation is now U squared, because I'm substituting this in and this in for these here. So the x to the 4th becomes U squared minus 9. The x squared is equal to U. We have a quadratic. So now you can use your different methods. You can use your factoring with this to find out what does U equal. And then, or you could use factoring, which is what we're going to do. All right, you could use completing the square if you wanted to, but I'm going to factor. So we have U times U is U squared. And then I know that 8 times 1 is 8, and a minus 8 and a minus 1 give you a minus 9. Which tells me that, using the zero product property, that one of those has to be 0, u equals 8, or u equals 1. Okay. But they don't want u. We want to know what x is equal to. So you'll have to substitute it. So here, u is 8. So 8 equals x squared. Or here, I'm going to switch it around, right? X squared equals 8. So u is x squared equals 8. X squared equals 1. All right? And then we take the square root of both sides. So x, kind of made it a long one, but didn't really necessarily have to do that. Take the square root of both sides. X equals plus or minus the square root of 8. We're kind of where we were before. Plus or minus the square root of 1. 2 square roots of 2. And then I will leave the check up to you to put it back in. But you see, we ended up with the same answer, just with a different method. So it's called u substitution. And you start out, you look at that middle term, and you let u equal that x value there, x squared. Okay? And we're going to do some more examples. I think I've got 4 or 5 of them to do here. And then you would kind of ignore this right now, and then square both sides of whatever you thought u should be. So we square both sides, multiply a power to a power, okay, and you get this. This should match your first term. You may have to have a number in front of it, but it should match your first term. All right, so there's our introduction to u substitution. Now, one of the things you need to do is here, like here we have 2a, let the u equal the middle term in the quadratic equation, excluding its coefficient. So notice I excluded, when I made my u, I didn't include the -9. You don't want to do that, okay? So just whatever those variables are. Now, one of the things that you need to make sure you do is that you don't stop here, because we don't want to know what u is. We want to know what x is. So you will have to go back to your original substitution. The u is x squared equals 8. The u is x squared, and now it equals 1, and solve those individually. And you might think, wow, this seems very tedious, but there are some problems where this will actually shorten the solving process. U substitution will. All right. Well, if I haven't confused you already, let's kind of move on and practice this. So, something like this right here. I've got here I've got this solved already using older methods. But here I have a squared, and then you actually have a linear term. So this actually, and we're going to use the u substitution here on this one. But what if you don't want to use the u substitution? You just want to stay away from the u substitution. Well, in order to solve this, there are some pitfalls in this solving without u substitution. There's some things you have to be very careful about. First off, you have to understand that when you square this, again, we're using methods without u substitution that we've used in the past. This squared means you've got 2 of them. So there's one of the pitfalls is realizing that you need to use the FOIL here. And the other pitfall is this negative changes the sign on everything on the inside. So what I'm going to do is I'm going to multiply this all out, simplify it, and then solve it. And so you have to be aware of those 2 things, that this means you've got 2 of them, and this negative will change the sign on everything on the outside. So when I use the FOIL method on these first 2, the first times the first, x to the 4th, minus 1x is a minus 2x, Negative 1 times the negative 1 is a positive 1. This right here, that's a negative x squared plus 1. And then the minus 2 is not a part of the changing of the signs because the minus 2 is not inside the parentheses. So now you clean this up. Once you've multiplied that out and distributed out that negative, you clean it all up, and that's what you end up with. So you've got the, this cancels 1, and 1 is 2, and a minus 2 is 0. Negative 2x squared and a negative 1x squared is a minus 3x squared, and you have the x to the 4th. So using our past methods, we know to use the greatest common factor first. So in this case, both of them have an x squared. Okay? So you factor out an x squared. Now check this when you factor it out, multiply it through, and make sure you come up with the line in front of that. Okay? And now using our product, our zero product property here, either this equals 0 or that equals 0. And we solve both of those. Well, in order for x to equal 0, x is 0. And because this is an even power here, this is actually a double root, which means it'll bounce at the 0, won't cross, because that's even power right there. But now this one right here, solving this one, okay, you add the 3 to both sides, take the square root, and don't forget your plus or minus. So if you look here, the highest power on this was an x to the 4th, all right? And I do have actually 4 solutions. This is called the double root. The 0 occurs twice. So I guess we only have 3 different ones. So we have plus the square root of 3, it will cross about 1.7. A negative 1.7 will cross the x-axis if we were finding the x-intercepts here. And at 0, it would kind of bounce off of that x-axis. All right? So it kind of looked like, let me go ahead and draw that. Just here's our 0. That's about, this is a negative square root of 3, positive square root of 3. It'll look something like this. Whoops, it kind of bounced and then cross again. Or it kind of bounces there at 0. Okay? All righty. So that would be not using substitution. Well, it's important to practice new ideas, even though maybe you don't need that new idea. Let's practice use substitution with this one. All right, here we go. You let u equal the middle term, and you ignore the coefficient. So I'm going to be ignoring that negative here. I will be ignoring that negative. So u is that middle term, and in this case, the middle term is x squared minus 1. Okay? And really, use substitution on this one is a little bit easier than using the other method, just because of those pitfalls there of knowing what the squared is or what to do with the negative outside the parentheses. On this one, you're not going to have to mess with that. I square both sides. Okay, so I square the u, and then I'm going to square this, and you do need parentheses because you want to square everything. You want to square the entire. Well, this does look like this, and this one looks like here. So I'm ready for my substitution. So don't make this part too hard. Just make that middle term the u, and then square it and square it. So when we do our substitution, this right here becomes u squared. So this right here becomes u squared. Then we have a minus. This is equal to u. And we still have that minus 2. So we factor this to find out what u is, all right? So here, I'm not going to use the quadratic formula. I only use it if I have to, especially something that's easy to factor. U times u gives you u squared. 2 times 1 gives you 2, and I want a minus 2. And negative 2u and 1u is a negative 1u. Perfect. So, zero product property. We're going to set both of these parentheses. They represent a number. One of these numbers needs to be 0. And we solve that. Add 2. So u is 2. And again, don't stop here because we're not interested in what u is. We're interested in what x is. So the u, you go back to your original substitution. In this case, that would be easier. So u is equal to x squared minus 1, x squared. So that, coming back up to the original, is equal to that. That is equal to that. And you solve these. And that's really not that hard because of this chapter. We know when you just have that squared term, or if you just had one cubed term, we could take the cube root of both sides, or the fourth root of both sides, or the fifth root of both sides in order to find that x. So now we add 1, so we isolate it. And then we take the square root. Plus or minus the square root of 3. Now again, remember, we should get the same answer that we did before in the other method. So then we have plus 1, x squared equals 0. And the square root is 0. So those are the 3 solutions. This just happens to be a double root. Okay, all righty. And I will leave the check up to you. You can substitute in the x and square it, subtract 1. It can be done. You have a calculator, so no problem. Just make sure you use parentheses when you substitute in a negative number into an even power. Okay, so that one, you know, this substitution really wasn't too bad, and there weren't the pitfalls of the negative, like I say, or knowing that the squared means 2 terms and use FOIL. Okay, all righty. Let's try another one. This one right here. All right, now this takes us back to chapter 10, solving this radical equation. And let's go through how we would have solved that radical equation. I have that right here. I think I even went through the check on this one. So awesome. All right, it's not D. Sorry. I originally it was, but I got rid of some of these. It's getting too close to the end of the year. Okay, so what we normally would have done back in chapter 10 is we would have isolated the term with the square in it, the square root, excuse me. Rather than moving the x and the 4 over, because this was a negative, I moved it over here so it became positive. Either way, you need to isolate the radical. Once you've isolated the radical, remember we squared both sides. All right. And so we square these, and I don't want my check. There we go. All right, so then we squared both sides once we isolated the radical. Now, again, remember, and I didn't write this all out, but this means x minus 4 times x minus 4. So even though I probably should have not have done that in my head. Okay. That's what this means. And you use your FOIL method. The first times the first, outside, out, inside, inside, outside, -8. The last times the last is 16. Now, when you square the right-hand side, remember that you square this, you get 9. The square roots, it cancels out and you end up with an x. So then, you set that equal to 0 so that we can factor it. Okay, so I brought the 9x over. So using the FOIL method, x times x is x squared, -16x and a -1x is a -17x. -16 times a -1 is a +16. So again, a lot of times we just want to use 8 and 2 or 4 and 4 for the 16. Don't forget about the 16 times 1. Using the zero product property, we have x minus 16, okay? So we have positive 16, and we ended up with x equaling 1. Okay, when you have a radical in your original, or you have a fraction in the original, it's imperative that you substitute your answers back in and check it, because there's a risk of one of these numbers not working. So with the check, I put 16 in for x. 16 minus 3 times 16 minus 4 equals 0. And simplifying that, this 16 minus 3 times the square root of 16 is 4. Okay. Multiply before you add or subtract. 0 equals 0. 16 checks. It's good. It's good to go. Now put in the negative, or excuse me, the positive 1. So if I put in 1 for x minus, oh, excuse me, I have a 16 there for some reason. 3 times 1, okay? And that gives you 1 minus 3 times 1 minus 4. Okay? And doing this further, let me move this up here. Oops, yeah, there we go. 1 minus 3 is our original. So then we come up with 1. Make sure you multiply. So we have 1 minus 3 minus 4 gives you a minus 6, which does not equal 0. So that means 1 does not work. Okay? 1 does not work. Your only solution is 16. So again, it's, you know, please, when you have those radicals and stuff, you really need to check. If you're not checking the others, which you should be, you got to, when you have a radical, especially, or a fraction, make sure it's not excluded from the domain, that answer. All right, so let's go through this using, let me set this over here, using substitution. Rather than isolating the radical and squaring both sides and factoring and checking, we're going to use u substitution. Well, you let your u equal the middle term without the coefficient. So our u is going to be equal to the square root of x. Okay. No problem. Then we're going to square both sides. So you square this u and you get u squared. When you square this, the radical disappears and you end up with x. So when you square that, the square and the square root cancel out and you end up with x to the first. So you see the substitution does work out quite well. So the x will become u squared. And the square root of x, becomes a u. And this, you might like this method better than isolating that square root and squaring both sides. And you know, sometimes it'll work, sometimes the substitution won't work. This ended up, because of the substitution, because that was an x there, if that had been an x cubed, it wouldn't have worked. But because it was an x, it ended up that we ended up with a quadratic that we could factor. Or you end up with a quadratic where you could use the quadratic formula on. For our purposes, I'm going to leave it so that you can factor them. So let's factor. U times u gives you u squared. A minus 4 and a positive 1 multiplied together give you a negative 4, but added together give you a negative 3. So now we set each of those equal to 0. And we come up with u is equaling 4 and u equaling a negative 1. But we don't want 4. Or we don't want, we don't want the u, okay? We want to know what x is. So we'll go back to our original substitution. And we know that u is equal to the square root of x. So when you get to this point, substitute it back. So we have u is the square root of x. U is the square root of x. Well, can the square root ever be this negative? Only if we have imaginary numbers, which we won't have here. But we'll go ahead and square both sides because the square root is already isolated. So we end up with x equaling 16. It's not plus or minus 16. You only have the plus or minus when your original is a squared and you're taking the square root to get rid of it. This is a square root and we're squaring. You just have the 16. It's if I would have had x squared equals, then, if we had that, x would have equaled plus or minus 2. It all depends on the original. This one, we're going to pretend that we don't realize that's no solution. We end up with x equals 1. Now, if you substitute these back in, which we already have done, we don't need to do that again. If you substitute in the 16, it works. If you substitute in the 1, it doesn't work. If you didn't recognize it here, that the square root doesn't equal the negative 1, we're not working with the x's can't be these imaginary numbers. It could have been I squared, but no. No, we'll just go with the real numbers, real solutions. Okay. Questions on that? All right. Well, obviously you guys can't ask questions. I don't know why we do that. It's a habit. Great. All right, now we've got 2 more to go. We're going to look at D here. All right, when we go through this one, this goes back to chapter 7 on how to solve this one. So this is a good review because it's been a while. So here's our original that I copied down. Negative exponents mean that they would come underneath. So I would rewrite it. 2 does not have a negative exponent. There's no parentheses. So the m squared comes underneath, plus this is 1 over m minus 15 equals 0. Okay, and solving an equation like this is what we would have done. Now then we have this fraction. So what we can do is we can eliminate the fractions by multiplying by something that m squared and m go into. So this is a method without substitution. Okay, and both of these go into m squared. So I would multiply it's just like multiplying by the least common denominator between these two. This is 15 over 1. So when you multiply m squared times 2 over m squared, and you can do this as long as you go with every term, even the 0. So multiplying the m squared through, it cancels here, and you end up with 2, plus this m cancels with one of those, so you end up with m to the first, minus 15 times m squared is m squared. So I'm eliminating these fractions, which is the nice thing about an equation. You have the opportunity to do that. And again, one other review hard part was that the 2 stays and the m squared comes underneath. The 1 stays and the m comes underneath. Now we're going to factor this. Well, before I factored, what I did is I rearranged it and I put the highest power first. And then I put the middle term and then I put the constant. But if you look here, this first term is negative. So I factored out a negative 1. So factoring out a negative 1, divide that by a negative 1, you get a positive. Divide that by a negative 1, divide that by a negative 1. Now, check this. Multiply it whenever you factor something out, multiply it through, and you should come back to the original, exactly the original. It's just I want to work with that leading coefficient as being positive. All righty. Now I'm going to factor what's inside. I'm just going to go ahead and bring this down. Even though it doesn't have an X with it, if it had an M, if there had been an M I factored out, I have to bring that down because that makes 0 a solution. Even though it's just a number, it's just a good habit. Bring it down, because when we solve it, it really has no significance since there's no variable. Okay, well, factoring this, I've already done that. 5m times 3m is 15m squared. -2 times a +1 is a -2. To get the middle term, the outside is 5m, and the inside is a -6m, which gives me a -1m. So I have these, so I factored it. Now I'll set them equal to 0, both of them. Either this number is 0 or this number is 0, and I will solve them. Add 2, divide by 5, m is 2/5. Subtract 1, and then divide by 3. A -1/3 is our other solution. Now, I do know that the domain excludes 0. If you go to the original, what we have up here, I know that m could not be a 0 because that would give you 0 in the denominator. Neither one of these are 0, but it wouldn't hurt to substitute them back in to the original for the m and make sure that the left is equal to the right. So I'll leave the check up to you. Let's use substitution on this one. Okay. Here we go. We're going to let u equal the middle term. Okay. And the coefficient is a 1. You just ignore it. Okay, now what I'm going to do is square both sides of my u. When I square this, I get u squared. When I square this, you multiply a power to a power. That gives you m to the -2, which is what we wanted. So now we'll substitute it back in, which gives us 2. M to the -2 is, so rather than this, I'm going to use u squared, because they're equal to each other. Plus m to the -1 is u, minus 15 equals 0. Okay, so now we'll just factor that. We kind of have an idea. 2u times u is 2u squared. Okay. 5 times 3 is 15, and we'll make it negative and a positive. Okay, equals 0. Let's just check it real quick. Our middle term, positive 6u and a -5u is a positive 1u. So it worked. We'll find our u. So we come up with 2u minus 5 equals 0. U plus 3 equals 0. Add 5. 2u equals 5. U is 5/2. Here we have u equals a -3. But again, we're not interested in what u is equal to. We're interested in what x is equal to. So we're going to substitute back in and review negative exponents. All right, here, u is m to the -1. On this step, you're substituting back. Now, how do you, oh, sorry. It's -3 on this one. So u, -3. U, 5/2. Now, m to the -1. That -1 means that it's 1 over m. So there's a couple ways you can look at this. 1 over m. So in order to find out what m is, because I don't want to know what 1 over m is, I want to know what m is. You can flip both sides. So you can, take a power to a negative 1. So m equals 2/5. So you can flip both sides. You can do that as long as you do it to both sides. Take both to a power of a negative 1. Same thing here. Negative 1, oops, negative 1. So you come up with m equaling negative 3 to the negative 1 power. You flip it. Okay, remember, the negative exponents don't change the sign, they change positions. So there's your answer, which is what the same thing we got before using the method of eliminating the fractions. All right. And neither one of those are 0, and I would put those back in and use your calculator to check to see if they're correct. All right, you guys are doing awesome. The last one. And this assignment does not have very many problems on it. So if you do have some questions or you're not really sure about that one, you can do another example. Just view another one and with my math lab so that you can practice a certain one, because I've only given you one of each of these. So anyways, now this one right here, I would just go straight to use substitution. All right, we've never really talked about different methods of solving this one. So I would just use substitution, and you do have one of these on your assignment. So we'll let u equal the middle term. U equals t to the 1/5. If I square this, how do you square this? Can you guys see that? I'm not writing too small. When you square that, what you're doing here is you have a power to a power. Well, 1/5 times 2 over 1 is 2/5. Kind of crowded there, but I think you guys can see that okay. So our substitution will work, because here you'll have your u squared, because when we square this, you multiply a power to a power, and then we'll have our u here. So when we do substitute in, we end up, this is u squared minus u is t to the 1/5. Okay, this is probably going to end up being one of our easier problems. Factoring, we have u times u. Let's see, 2 times 1 is 2, negative 2 and a positive 1. So negative 2u and a positive 1u give you a negative 1u. Perfect. So checking the FOIL method, it works. Setting both of these equal to 0, we get u equals 2, or u equals a negative 1. Now you're thinking, okay, a negative 1, I've got these this fifth root. Because it's a fifth root, you could have a negative because it's an odd root. So now we're going to substitute back in. So I'm going to have t to the 1/5 equals 2. T to the 1/5 equals a negative 1. To get rid of this 1/5, it's actually a fifth root. We're going to take it to a power of 5. 1/5 times 5 is t. 2 to the 5th is 32. Okay, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Take it to a power of 5 to get rid of the 1/5. Negative 1, this is an odd, so the negative stays, and 1 times 1 times 1 times 1 times 1 is 1. Okay. And then you would substitute those back in and make sure they worked. All right, now, and again, maybe this part may give people issues. solving this, just remember that t to the 1/5 is the same thing as the 5th root of t. As an example here, these two statements mean the same thing. So to get rid of this radical, you go to a power of 5. That's another way of looking at it, or realizing that 1/5 times 5 is 1. Alrighty, and then put those back in and check to see if they both work. Okay, so or if they both work. And I guess that's all for this section. Like I say, I wish I could communicate with you guys right now, but go ahead and do the best you can, and I can just encourage you to contact me. I've got one more section to do, and that's 11.6, and that's graphing. So, all right, well, you guys have a great day. Good luck with this. Pay attention to due dates. All right, and contact me if you need any help. Thank you.